Hello, geometry class. Today we are going to learn about a cool new topic called trigonometry. So trigonometry is the study of measuring on triangles, and we have three trig ratios that we use: sine, cosine, and tangent. There's a little acronym that you can remember that will help you to set up your trig ratios correctly. SOHCAHTOA. It's SOHCAHTOA. Kind of like you're soaking your toe in some water or something. So this will help you to remember what goes where in the equations. So if you take a look, well, first of all, you need to know that these trig ratios are going to be used on our right triangles. So you should see a right angle here. The sine of the angle A is equal to the opposite leg over the hypotenuse. So the opposite is the one that is across from it. And the hypotenuse, of course, is the longest side. That won't change. It's always the longest side. So the SOH stands for sine equals opposite over hypotenuse. Then the cosine of the angle A is equal to the adjacent leg over the hypotenuse. So the adjacent side is the one that touches the angle but is not the hypotenuse. So the opposite one is not touching it. Like if I put my finger on the angle, the opposite side is the one that my finger does not touch. But the adjacent side does touch the angle and it is not the hypotenuse. So the cosine of the angle A is equal to the adjacent side over the hypotenuse. And last, the tangent of the angle A is equal to the opposite side over the adjacent side. So you don't use the hypotenuse at all when you're doing the tangent, just the two legs. Okay, so the order of all this stuff matters. On this first example, it tells us to find the sine of J, the cosine of J, the tangent of J, and then the sine of L, the cosine of L, and the tangent of L. Express each ratio as a fraction and as a decimal to the nearest hundredth if necessary. So we have quite a bit to do on this one problem. We'll just do number one and skip number two. We're going to do the sine of J, the cosine of J, the tangent of J, and then we're going to switch and we're going to do the sine of L, the cosine of L, and the tangent of L. Okay, so remember that the sine is equal to the opposite over the hypotenuse, SOH. So if I start at angle J, I want to say which side is opposite from angle J. That's the one that is across from it. If I put my finger on angle J, it is the side that my finger is not touching. So that's going to be the 12. That's the one that's opposite from angle J. Now the hypotenuse stays the same in the whole problem. The hypotenuse is 20. It's the longest side on the triangle. It's the one across from the 90. We've been talking about the hypotenuse a lot lately with the Pythagorean theorem and special right triangles problems. So here is my fraction. But this is not a simplified fraction because 4 will go into both of these numbers. So 12 divided by 4 is 3, and 20 divided by 4 is 5. So 3/5 would be the fraction answer that we're looking for. Then they also want it as a decimal. So in my calculator, I'm going to type 3 divided by 5, and that gives us 0.6 as a decimal. So there's my decimal answer. Okay, now we're going to do the cosine of J. If I start at angle J, the cosine, of course, is equal to the adjacent side over the hypotenuse. That's from the CAH, part of SOHCAHTOA. And so if I look at angle J, which side is adjacent to angle J? It's the side that's touching it that is not the hypotenuse. So that's 16 for this problem. over the hypotenuse, which is 20. And that fraction is not simplified because 4 goes into both. 16 divided by 4 is 4. 20 divided by 4 is 5. So 4/5 would be my simplified fraction answer. And then I can go 4 divided by 5 equals 0.8 for my decimal. All right, the tangent of J. Tangent is equal to the opposite side over the adjacent side. That's the TOA part of the SOHCAHTOA, the last one, TOA. Tangent of the angle is equal to the opposite side over the adjacent side. So from angle J, we already noticed that the opposite side was 12 and the adjacent side was 16. So 12 and 16 are both divisible by 4, so we can simplify this fraction to 3/4. And 3/4 as a decimal is 0.75. So you can put equals 0.75. All right. Now we're going to switch gears and we're going to work from angle L. So the sine of angle L is equal to the opposite over the hypotenuse. Now from angle L, the side that's opposite from it is the side that when I put my finger on L, my finger is not touching that side. So that's the 16. And the hypotenuse is still 20. That's not going to change. Now we already talked about 16/20 up here. That simplifies to 4/5 and it equals 0.8 as a decimal. Now for the cosine of angle L, this is equal to the adjacent side over the hypotenuse. The side that is adjacent to angle L is 12. That's the side that it is touching but is not the hypotenuse. And the hypotenuse is still 20. And we did this fraction 12 over 20 up here. So that's going to simplify to 3/5 as a fraction. And the decimal equivalent is 0.6. Now, the last one, the tangent of angle L, is equal to the opposite over the adjacent. From angle L, the opposite side is 16. The adjacent side is 12. We already identified those. And then 16 over 12 is not simplified because you can divide by 4 on both. So 4/3 would be the simplified fraction. And then to get that as a decimal, 4 divided by 3 gives us 1.3 repeating. And it says to round the decimal to the nearest hundredth if necessary, which means we're going to put 2 numbers after the decimal, 1.33. And that's the answer. All right. The next part says use a special right triangle to express each trigonometric ratio as a fraction and as a decimal to the nearest hundredth if necessary. We're just going to do these as decimals. If this was a pre-AP class, I would work on the fractions and drawing the pictures of the special right triangles, but we're just going to practice doing this in the calculator for the purpose of this activity. Now, one very important thing that you need to know is that in geometry, when we are studying trigonometry, we have to have our calculators set into degree mode. So if you hit the mode button on your calculator, which is next to the second button, hit mode, you're going to get this menu. And on the third line down, it has radians, which are highlighted, and degrees, which are not. Now, radians are another way of measuring angles that is different from degrees. We work with degrees in geometry. We work with radians more once you're in pre-calculus. And actually, from there on out, you use radians a whole lot more than you use degrees. So it's probably the more common angle measurement, but it doesn't really come around much earlier in math. It's more as you learn more and you get further in your mathematical career that you'll use radians. So the default mode is to radians, but you have to go arrow down and over to the word degree and press enter to switch your calculator into degree mode. Now it's going to stay in degree mode until you do one of two things. you either go back into the mode and switch it back onto the radians, or if you clear the memory in your calculator by pressing second plus 712, that's going to reset the default to the radian setting instead of being on degrees. So if you're a person who clears your calculator a lot, you need to know that you're going to have to put it back into degree mode anytime you do that, or you're going to get the answers wrong. And I'll show you that on this first problem, number 3. It says to find the sine of 30 degrees. So I'm going to hit second and the mode button again to quit and go back to the home screen. And I'm going to type sine. Now you have the sine, cosine, and tangent buttons. Those are above the number 7, 8, and 9, 2 buttons up. So we're going to hit sine, which makes this pop up on your screen with the little open parentheses. And we're going to type 30. You can close the parentheses, or you don't have to close the parentheses. It will give you the same thing either way. But you're going to press enter. And this gives you the answer of 0.5, which is the answer that we want for this problem. Now, what if you had your calculator in the radian mode? I'm going to go back to mode and switch it to radian mode. Go back to my home screen, and now I'm going to type sine of 30 again. Look, this is not the same answer, and this is not the correct answer for what we're doing. That's the sine of 30 radians, not 30 degrees. It's kind of like the difference between measuring in centimeters and inches, okay? It's just a different way to measure. It's a different unit. And we're using degrees for these problems, not radians. So make sure that your mode is in degree mode so that when you type sine of 30, you're going to get 0.5, okay? All right, next one, number 4. Tangent of 45. So I'm going to hit the tangent button in my calculator, and then I'm going to type 45 and press enter, and it gives me 1. So this equals 1. Now we're going to do the cosine of 60. Cosine 60, enter, 0.5. Now we're going to do the sine of 60. Sine, 60, I don't need the parentheses. It is, okay, we've got a decimal that's lengthy. We need to check our rounding instructions. It says to the nearest hundredth, so 2 numbers after the decimal. 0.866 would round up to 0.87. Okay, now let's do the tangent of 30. Tangent 30, enter. 0.577 would round to 0.58, rounding to the hundredths place. That's 2 numbers after your decimal. And then the last one, cosine 45. This 0.707 is going to round to 0.71. That's the answer. Okay. Now let's move on to the back. We can use SOHCAHTOA to find missing sides on a triangle. And that's what we're going to do on these 4 problems. So it says find x, round to the nearest hundredth. Okay? So the first thing that we need to do is look from the angle that's marked. This one is 64 degrees. We need to label the sides that have either x's or numbers on them. So from the 64 degrees, I can see that the x is the opposite side, and the 11 is the side that's touching the 64 but is not the hypotenuse. So this one is called the adjacent side. Now, which one of these 3 trig functions, sine, cosine, or tangent, has the opposite and the adjacent in it, the O and the A? The O and the A are in the tangent, so we have to use tangent to solve this problem. So we're going to say the tangent of 64 degrees, because the angle always follows the trig function, equals the opposite side, which is x, over the adjacent side, which is 11. Now, to get the x by itself, since it's divided by 11, I have to multiply by 11 on both sides. So I'll have 11 times the tangent of 64 equals x. And now I'm going to go into my calculator and just type that in. 11 tangent 64, enter. And that gives me 22 point, what did it say, round to the hundredth? So 2 numbers after the decimal, 55. 22.55 equals x. So we just used the tangent function to find this missing side of the triangle, okay? Now, let's take a look at number 10. On number 10, we have this angle with the 29. We need to label the sides. That's our first step, label the sides. So this 29 is on the hypotenuse. It's the longest side across from the 90. The x is on the side that's touching the 29 degree angle, but it is not the hypotenuse, so that's called your adjacent side. We're not using the opposite side at all for this problem because there's no variable or number written on that side. So which one of these three trig functions has both the h and the a, the hypotenuse and the adjacent side? The a and the h are in the cosine function. So I'm going to say the cosine of 29 degrees, because the angle always goes right after the trig function, equals the adjacent side, which is x, over the hypotenuse, which is 29. The letters go in the order of the fraction. The first number goes on top, second number goes on bottom. Now, to get the x by itself, I have to multiply both sides times the 29 because it's divided by 29. So, now I'm going to go to my calculator and type 29 cosine 29. And that gives me 25.36 rounded to the hundredths place. 25.36 equals x. All right, number 11. We have a 15 degree angle here. The 12 side is the hypotenuse. It's across from the 90. It's the longest side. The x side is the one that if I cover up my 15 degree angle, my finger is not touching. So that's the opposite side. So which one of the three trig functions uses the h and the o? That's the sine. Sine of 15 degrees, the angle always goes after the trig function, equals o, which is the opposite, that's the x side, over h. H is the hypotenuse, that's 12 for this problem. Now, because I have x divided by 12, I have to multiply both sides by 12 to get the x by itself. So 12 times the sine of 15 degrees will equal x. 12 times the sine of 15 degrees equals 3.11. That 5 is going to round the 0 up to 1. 3.11 is what x is equal to on this problem. All right. Number 12, this time we're starting with the 63 degree angle. We're going to label our sides. X is on the hypotenuse, the longest side that's across from the 90. If I put my finger on the 63, my finger is not touching the side with the 12, so that's the opposite side. And which trig function, sine, cosine, or tangent, uses the o and the h? That's your sine. Sine of 63 degrees, the angle always goes after the trig function, equals the opposite side, which is 12, over the hypotenuse, which is x. Now, this one is a little bit different because in all the others, the x was on the top. Now the x is on the bottom. I'm going to start this one just the way I did on the others. I'm going to multiply both sides by x so that I get it out of the bottom of the fraction, because you can't solve for x when it's on the bottom of a fraction. And now I want to get the x by itself, so I'm going to divide both sides by the sine of 63 since it's being multiplied by the sine of 63. So those will cancel. So x is equal to 12 divided by the sine of 63. And that's what I'm going to type in my calculator. 12 divided by the sine of 63. And that gives me 13.47. That's going to round to 13.47. Okay? Now, the remaining problems are a little bit different, and we're splitting our trig lesson up into 2 parts. So, we're going to stop here, and my next video will have information about those other problems. All the ones we've done so far have been about finding a missing side length on a triangle. The next kind that we're going to get into are going to be asking you to find the measure of an angle. So that's going to be a little bit different, and we'll get into that in our next lesson. Have a wonderful day. Good luck with your homework. Please let me know if you need any help. Bye for now.